looking at here then is if we are to draw a sketch of that, okay? First off, what is your parent function?
Man, that's cubic.
That is your cubic. So we're going to draw ourselves a little XY coordinate plane. We know what a cubic looks like, yes? Basic idea is that S shape, okay? I don't need a whole lot of points for the S shape. I really need to know like the middle of it, yes? Usually starts at 0, 0. If this is moved, which way is this telling me to move it? Right one. That just means that my S shape starts in the middle at 1, 0 and goes like that. So if I know the basic parent function, the basic transformations, I can then give myself a sketch that I can look at to say, what's the domain? How far does this go to the left and to the right?
Still all real numbers.
Still all real numbers. Range is still
All real numbers.
all real numbers. Yay. Easy enough. I'm not looking for like very detailed sketches here. There are times in piecewise functions that you will want to get like certain points to know whether some of the pieces connect or not. But like on these, I just need the basics, okay? So if I look at example 2, I'm going to say to myself first, what is my parent function? Quadratic. Now this one has 2 transformations on it, right? So this is a quadratic. First, this transformation tells me it's moved which way? Careful. Up 3. If it was like in with the x squared, then we would say it's left and right. If it's at the end, not inside the squared, then that's your up and down. So we've got that as up 3. And this negative 1/2 out front tells me 2 separate things. One of them is, it's kind of like the slope for the quadratic. It tells me how wide or narrow it is. We'll use that just to say it's a little bit wider than normal. We're not going to use a whole lot of details on that. What does the negative mean?
Yeah, that goes the other way around.
Yep, it's a reflection. So we've got a reflection over specifically the y-axis, but really we just think about it's like flipped upside down, okay? So when I graph this, I say to myself, I need to start my quadratic up 3. And I'm just going to say next to this one, it's a reflection and wider. Because as long as I know it's a little bit wider, I really don't need a whole lot of details here. So instead of doing my normal quadratic that would look kind of like that, I would probably just widen it slightly to make it show that something happened and make it kind of look a little bit wider than normal. Okay. The 1/2 out front. Usually there's a 1 out front. So we have like a normal width for a quadratic. A 1/2 pulls it wider. So if it's a fraction between 0 and 1, it goes wider. If it's a bigger number like 2, 3, 4 in front of the x squared, it makes it skinnier. Yes? Any questions on that one? All right, let's look at example 3. So in example 3, what is my parent function? We got a square root function. This one also has multiple transformations on it. Oops, I didn't state domain and range. Let's go back to that. Domain for my quadratic. Infinite, all real numbers. Either way you want to put that. Now, range on quadratics, I do have to think about. Remember, range for y values, you want to always go bottom to top.
Negative infinite 2, 3.
So this starts at negative infinity and goes all the way up to the highest y value of 3. Do I use a bracket or a parentheses? Bracket. Good. Now, let's talk example 3. All right, so I've got a square root function with a couple different transformations on it. This one is inside with the x. Okay, so is that left, right, or up, down?
Left, right.
Left, right. Which way?
To the left.
That's left 2. What is, bless you, what is the negative? That's a reflection or a flip. Okay. And what does the 2 do? We call that a stretch. It's kind of like that 1/2 in the last one. The 1/2 made the quadratic wider. This is going to make the square root kind of like taller. In this case, it's going to be upside down, so it's going to feel like it makes it lower. But all I really need to know mainly is the starting point. So normally, my square root function starts at 0, 0 and goes out that way, right? So now let's do the first 2 transformations, the left 2 and the reflection. If I do the left 2 and the reflection, it now starts here and goes upside down, right? All I do with that 2 is say this is kind of how it would normally look. A 2 might make it just kind of go more down, like make it kind of wider that way. vertically stretch it. That's what we call it. Now, what would I say for a domain on this one? How far does it go to the left? -2. And how far does it go to the right? Infinity. What about a range on this one? Negative infinity to 0. There you go. You have to go bottom up to the highest, which is 0. Good. Is this mostly familiar? Review? Yeah. Yes, ma'am.
I forgot how you...
So on example 4, first, what is my parent function? Yeah, it's a rational, right? Now, this one feels a little bit different when you do transformations because there's not really points for a rational function, right? Usually we know the cubic goes through the middle and makes an S shape, and we know the quadratic goes through the middle and makes a U shape. The rational doesn't really have points on it, so what we move instead is the asymptotes, like the breaks in the middle. So the rational has the asymptote at 0 and 0, okay? So when I read the transformations for this, it's still, that is like what inside with x is on a rational. Inside with x on an absolute value is inside the bars. Inside with x on a quadratic is inside the squared. This one is like on the bottom. So this is going to move it which way if it's in with x? Right 2. Good. And then the up and down is going to be at the end here. So that's going to move it up 3. So when I graph a rational with transformations, wow, that's bad. I really just want to start with doing the asymptotes. I've moved my asymptote from 0, 0, or from 0 in the middle to right 2. And I've moved my asymptote here up 3. Now, the normal rational function has branches. We call them branches where?
Right, left, or
Bottom
right,
left, top right, right? So if there is a negative in there somewhere, then they will flip. Is there a negative in that one part?
Nah.
No. So that just means my branches are still in the sections that I would expect them to be in. Now, I do have to be a little bit careful with the rational domain and range, right? We practiced that on last night's homework. So if I said my domain on this, I would say, either I can say negative infinity to the asymptote to infinity, or do we like the all real numbers x does not equal?
It depends how many.
Yeah, same as I am on that one. I don't care, whichever way we're comfortable. So you could say on this one, all real numbers, x does not equal. What value can x not equal?
You got like half there.
Well, what gives me the asymptote for x? 2. Just 2. And that's also what would give me 0 on the bottom of the fraction, just like we talked about in last night's homework, right? Or you could put negative infinity to 2 to infinity. For my range, I do the exact same thing. The only thing with the all real numbers notation that you need to be careful of on this one, range is referring to what values? Y's, right? So if I do my all real numbers, this time I have to say y does not equal, not x does not equal, because we're not talking about x's. What can y not equal?
And
3. There's no good rule of thumb on like the fraction for what y cannot equal. Because like for the x's, you can say you can't have what makes the bottom equal to 0, right? For the y, you just have to know where the asymptote is and skip that. Again, you could also put that as negative infinity to 3 and 3 to infinity. Either one. Any questions on those? If I'm looking at example 5 here, first function. I like to do my stuff in colored stuff, but if you are doing pencil, that's great too. What is the function y equals x? That's just a line, okay? It has what y-intercept? 0, and what slope? 1. All right, so I'm just going to graph that whole thing initially. I'm going to start with a y-intercept of 0. And I am going to go ahead and just graph a couple points. It has a slope of 1, so it goes up 1 over 1, down 1, left 1. So if I connected my dots, they would all make a line, yes? That is my line y equals x. So now let's go back and look at the restrictions on it. I want my points to be between 0 and 3, yes? All right, so if I was doing this, I would say, okay, this point is 0, yeah? I want nothing to the left of 0. I want to keep the section between 0 and 3. So that means I do not need these points, And I only need the ones I have, but I do have to make one change to them, right? Do you remember open dot, close dot stuff? If I look at my restriction up here, it tells me that this needs to end with what kind of dot? An open. So I'm going to erase this last dot I have going on here and make it an open dot. So I have that. And I'm going to connect my dots in one little chunk of a line. We all okay with that? There's no harm in doing this and erasing pieces. If you're more likely to get it right that way, do it. Don't try to do it the hard way and know exactly what you have to do. Others of you know how to plug in 0 and then plug in 3 and just connect the dots between the two, and that's fine. You can do that too. The second chunk is another line. Yes? That line has what slope and what y-intercept? One slope, negative 1 y-intercept. So normally to graph a line, we start at your y-intercept and we do your slope, right? I recognize that this chunk is not starting at 0, but we're going to use it to help us get out there. So I start at negative 1, and this one also has a slope of 1, so it's going to go kind of parallel to this one. And I'm going to draw a couple dots out this way, because if I look at my restrictions, they're further out. So looking at my restrictions now, this one says I want to keep x values between where and where? 3 and 5. So I want to erase any x values before 3, which is this one, and this one. And I want to erase any x values after 5, which are these two. Should I have closed dots at both ends on this one? Yes. So now that I have that, I then connect these in another little line chunk. Okay. And then finally, third piece. What kind of graph is 4? Straight line which way? Horizontal, because although it's out here, this is still y equals 4. Y equals 4, horizontal line, yes? So my horizontal line would go all the way through at 4. So I can draw that whole thing in and erase pieces. I can draw the dots at 4 and erase pieces. It doesn't really matter, okay? This one says we would like to go from 5 to 7. What kind of dot does it need at 5? An open dot. Okay, so I'm going to erase up to 5. Now, looking at my graph here, if I put an open dot right here at 5 on top of a closed dot, what's really there? A closed dot, right? Because we all know the closed dot rules, right? Then I only want that chunk to go out to 7, which is right here. So if I put an open dot right there on top of a closed dot, it's still a closed dot. And then I want that to go out to 7. So I erase my chunk to the right. So this is just a little couple line piece.
For the second one,
Mm-hmm.
why is it going 2 to 4 instead of 3 to 5?
Why is it going where?
Oh, never mind.
No, you got it? Okay. All right, now with this, it doesn't say it specifically here, but one thing we do with piecewise functions is sometimes we write our domain and range. Okay? So remember, for domain, you have to ask yourself, does it go through all x values or just some of them? So how far does this graph go to the left, or where does it start? 0. Okay, so I start at 0. Now, if I go through my graph here, okay, so I follow this out. This has an open dot, but what's directly underneath it? A closed, so I can jump. Keep going. This has a closed dot, an open dot. I can stay there, keep going. It goes out to where? 7. So you are telling me that this graph touches every x value between 0 and 7. Yes? Does that make sense to us? Okay, so then I do the same thing with the y values. What's the lowest y value that this touches? 0. Range. It goes from, that's a really bad R, goodness. All right, range goes from 0. Now, some of us get hung up on open dots for range, okay, because it makes us feel like we can't touch this. But if I go bottom to top and kind of slide the whole way up here, yes, this is an open dot, but do I have a y value that matches that over here?
Yeah.
Yes. So I can go from 0 the whole way up to a y value of what? 4. Good. Not so bad? Maybe better than they were? That's our hope. Alrighty. In that case, let us go down and we'll do 6. And then we'll talk about plugging in numbers to piecewise functions, and then I'm done with notes. It's a glorious Friday. Yes. All right, so let us, ooh, I didn't do that in the last one. Okay, let's look at this one. One piece at a time. See if you can graph that one on your graph. Just the first one. Just the first one. We'll go after the second one in a minute. When I am looking at this one, I start at -8, and I give myself a slope of 2. And I draw myself a couple dots before I ever look at my restrictions. This one has a just x is less than 2. Okay? So if I want just x is less than 2, I want my line to start at 2 and go which way, left or right? Left. I want the less than chunk, the less chunk. So that means I erase anything past 2. What kind of dot do I want it to start with it to? An open dot. Okay, so I'm going to make that dot I have right there an open dot. And I'm going to connect my dots headed off to the left there. How'd we do getting our first piece? So-so? All right, let's look at the second one then. What is this guy? It's an absolute value function. Has a couple transformations on it. Which way is it moved? Right 3, up 1, and upside down. Okay, so I'm going to take my absolute value, go right 3, up 1, starts here, and it goes like this-ish. Okay, and I've drawn the whole thing. Okay, but let's now look at the restrictions. I only want that piece to be there between what x values? 2 and 4. All right, so here it is at 2. Here it is at 4. I only want to keep the section between them. So what's that section going to look like?
Little upside down B.
Yeah, a little upside down B. I don't want this piece, and I don't want that piece. Okay? Questions on that one?
Are we going to do anything with decimals?
No. You can't use it on a test. You know what I mean? Like, I need you to be able to do this. We could. I don't do projects.
Oh.
No.
I got one
You
ready.
don't like that?
I got one ready.
No, there you go. All right, so then my last one here. That is a what?
Man, that's a cubic.
That's a cubic. That's a cubic moved which way? Right 4, up 3. And again, for those that are kind of like, what piece do I keep? I'm going to draw the whole thing. So right 4, up 3 would be S shape, that piece goes this way. Now I'm going to really see if this eraser works well, because it supposedly will let me erase just one piece that I've drawn. We'll see. So this one, we want the section that is larger than 4. Okay, so which piece? The right piece from 4 or the left piece from 4?
Right.
I want the right one. So I need to erase. No, that's not what I wanted to do. I just want to erase the top part here. It's not going to do it. All right, boo. I thought it would let me fix that. The only thing that I messed up, not messed up, but just haven't done yet because we got Miss Pyle talking to me, is what? That section needs to start with what kind of dot? Open dot. So I do need to erase my dot right here, and that piece needs to start with an open dot right there. Now this one we have to be a little careful with on domain and range, right? So if I do my domain and range, and then I'll look at the plugging in values, my domain, how far does this go to the left? Negative infinity. Good, because that blue piece keeps going. Now, if I kind of trace through it, coming back through, I come up here. This allows me to hop up here. It keeps going. This allows me to hop up here. It keeps going. So where does it go out to? Infinity. So it looks weird, but the domain works fine. Now, the range, not so much. Yeah? So the range, you got to tell me when we're missing pieces of this. Okay? So we're going bottom to top on this. So this first piece starts where? Negative infinity comes up to -4. What kind of symbol do I put there? Bracket or parentheses? Parentheses with that -4. Then I'm jumping up to the next section. This section starts at what y value? 0 and goes up to 1. Okay? And those are brackets or parentheses. Bracket, bracket. Good. And finally, the top section starts at what y value? 3 and goes out to infinity. So you got all three pieces there, and that should be with parentheses. Okay? So the last thing on this graph that we want to talk about is f of values. Some of them are straightforward and some of them are not, which leads into our last question, what you can do without graphing. Okay? So if I'm asked to find f of -3, what should I do with my graph? I should look at x equals -3, follow it to the line that is here, and say what y value would that be at? Okay, now would I have to kind of like track this line out further to get that? Yes, I would. So you could do that, or I'll show you an easier way without tracking your line out. If it's something simple like f of 2, okay, f of 2 is right here. What's f of 2? 0. That's great. Nice and easy with a graph. If it's not on the graph, I want to show you another way, okay? And then my last one, f of 5. f of 5, what do you think that is?
Between 3 and 4.
Okay, somewhere in here. Now, are we sure what it is?
Yes.
Okay, if you remember enough of a cubic, you know it goes up 1 over 1, and you know it's at 4. If you're not sure and you think your graph might stink, or like this one and I don't want to track it out, here's the other way you can do these. Without looking at the graph, look at the piecewise function itself. -3 fits into one of these three categories. Which one? The first one. It's less than 2, yes? So I can take -3 and I can plug it into the equation that's with it. 2 times -3 is what? -6 minus 8 is -14. So graph or no graph, you just plug it into the section it goes with. Same thing with 5. If you're not sure that this goes through exactly 4, don't guess. Plug it in, okay? So this one, f of 5, I would say, okay, 5 is greater than 4. Therefore, I plug it into the third section. All right, so that would look like 5 minus 4 all cubed plus 3. Well, 5 minus 4 is just what? 1, and 1 cubed is just 1. 1 plus 1 is 4. Okay? 1 plus 3. Sorry. I'm thinking the right thing, saying the wrong. Thank you. All right, so using that same concept, let's look at our last example here, 7. Without graphing, let's find these three values. So if I'm looking at this, f of 0, which one of those three does 0 fit within? The first one. Now, is there anywhere to plug it in right here? No. But that just means my y value is what? 1. All right, so then f of 2, which one does that fit in? The second one. And that one you got to look at the equal to or the not equal to, right? Equal to or just simply greater than. So if 2 fits in that one, I plug it into x squared. What do I get back out? 4. And f of 7 fits into which one? The bottom one. So I plug it into that equation and I get what? 4. Questions, comments, or concerns? Okay, we're done.